In this video, we're going to take a look at our second case where we're dealing with a mean hypothesis test for a mean with two independent samples. In this second case, we know the values for sigma 1 and sigma 2. So notationally, again, subscripts of 1 will deal with population in sample 1, and subscripts of 2 will deal with population in sample 2. For this test, when we know the value of sigma 1 and sigma 2, instead of having a t distribution and a t statistic, we have a z statistic when we know the values of sigma 1 and sigma 2. Our confidence interval, it is calculated in a similar fashion, but what's different here is that margin of error is going to be calculated differently. The interpretation of that confidence interval would be exactly the same as it was before. In terms of rolling through this in StatDisk, we need to do the same thing. We are going to choose that same mean, two independent samples, but the difference is this time we know the value for population standard deviation 1 and population standard deviation 2. And so when it outputs, when we include those values, the output is going to output z values instead of t values. All right, so let's look at an example. This example should look familiar. A study was conducted on arrival delays for two different recurring flights. Here are the summary statistics, so we will call this population 1, and this population 2, or sample 1 and sample 2, however you want to think about that. Suppose that among all flights, flight 1 has a standard deviation of 12.4. So among all flights, and also among all flights, flight 2 has a standard deviation of 15.6. So what that's telling us is it gives us a value for sigma 1, the standard deviation of all flights is 12.4. Standard deviation of all flights 2 is 15.6. Again, the same claim is we're using the 0.05 significance level to test the claim that they have the same mean. So the claim is mu1 equals mu2. The opposite is they're not the same. mu1 not equal mu2. So from this, our null hypothesis mu1 equals mu2, and the alternative mu1 not equal to mu2. So this would be a two-tailed test. We're going to go to StatDisk with all of these values, and let's roll with it. So over in StatDisk, we choose Analysis. We are doing a hypothesis test. That hypothesis test is mean two independent samples. Our alternative hypothesis is that the population mean 1 is not equal to population mean 2, so that is correct. Significance level is 0.05. We have 12 is sample size 1. I don't remember what this value is. It's a negative. I do remember that much. So for 1, we have negative 20.5 and 12.38. population standard deviation, that extra piece of information, that was given to us here. Right? So we were told 12.4 was our population standard deviation. Among all flights, the standard deviation is 12.4. For sample 2, our sample size again was 12. Our second value again was a negative value that I don't recall off the top of my head. That value was negative 15.08 and 15.62. And we were also given a population standard deviation that was 15.6. I'll go back to our notes one more time. So, among all flights, Flight 2 has a standard deviation of 15.6. So that is for the entire population. Right. So now we can go evaluate this. And when we evaluate it, here is our output. Notice that we have Z statistics instead of T statistics. Our p-value is 0.3461. And so we observe that that p-value is bigger than our significance level of 0.05. P-value is high, so the null will fly. So we fail. To reject the null. Again, in this problem, it asks us to identify the associated confidence interval. And so that was provided here. Down there at the bottom, negative 16.695 to 5.855. So negative 16.695. Notice here that 0 is in the confidence interval. So mean 1 being equal to mean 2 is reasonable. So that's something that's reasonable to believe. Notice that these values here, if we go back to our last time we did this example, where the only thing that was different was we weren't given this information, but in our last video, we saw 17.388 to 6.548. Those values are not significantly different from these. Also, that p-value 0.3461 before was 0.3569. So it didn't change a whole lot based on these new values, but it did change. So be really careful with those. We'll see you in the next video where we discuss the third case.